Hi, guys, and welcome to the show. This is not just an average show. This is episode 75 of Taste of Premiere. And so we are incredibly grateful that you guys have watched us over the years and that we even made it to an episode 75. I think that's incredible. But even more incredible is today's guest. Joining us for the third year in a row, we have Norm Judah. So play the music. Hey guys, like I said in the intro, we have Norm Judah with us, and Norm has joined the call. Norm, how are you?
I'm doing great. Congratulations, Lex, on number 75. It's a great goal to get to. Now you got to get to number 100 after this one.
Oh yeah, that's definitely going to happen. I can't wait for that.
The Super Bowl of radio.
Yeah. So, yeah, when this started, it was just a stupid little idea that we had, kind of tell customers about some of our service offerings and just talk things, all things Microsoft. And it's pretty amazing. We've had, millions of hits now. We've had episodes that have, gotten over 250,000 views. So it's pretty amazing.
That is great. Yeah, good stuff.
Yeah. So the last few years, we talked about, where technology is heading and what we see as the future of IT. And we did that great thing with Arthur C. Clarke. And I look forward to doing this with you because the insights that you have are so cool. It's so neat to listen to some of the stuff that probably you have better insight into than kind of the average person.
I think what's interesting where we are sort of as a period of time is that there is so much happening now. There's so much change that's going on that if we look back a year or two and then look forward, the rate of change coming forward is amazing, even faster than we've had over the last couple of years. We've come from this place of a little bit of experimentation and suddenly seeing this resurgence of stuff that is real. So this is not necessarily about the future, but the future is kind of now on many of these things. We can always look ahead, but there's a lot of stuff going on now that's really, really interesting.
Yeah, absolutely. And speaking of that, we just released the developer version of HoloLens.
Yep. It's gone out around the Build conference. There's now, as a developer, you can get access. There's some great videos that are tutorials about how to build a HoloLens app. And it is just a Windows 10 device. I mean, the thing is actually you can be domain joined. You can have DRM documents on it. You can actually manage deployment to it as you would any desktop or laptop or phone for that matter. So the developer experience in that sense is very similar, very confident in terms of what you've done. But it's very different in some of the cases where you're actually developing these new 3D objects and how you actually do them. And so what we find interesting is that to develop a HoloLens app is not just a code developer, but you've got to have somebody who understands audio, somebody who understands video, somebody who understands sort of a lot about gaming in order to produce it. And so we're seeing new classes, new generations of applications that before people were imagining or they were doing 3D and 2D. That's now allowing us to do some very, very different things.
Yeah, you have to be actually spatially aware as well.
You do. And the kinds of applications, the kinds of scenarios that we're seeing companies do in the commercial space, I won't necessarily talk about the consumer. In the commercial space, there are some amazing things. I mean, there's a company called Trimble that's doing construction, for example. And so when you typically see a new building going up, you can go into the lobby somewhere or some adjacent site and you'll see a model, which is there's been some architectural student who's actually built that model very accurately about what the diagrams, the construction view looks like. But when you do that in a virtual space, it's so different because you actually see, firstly you see the building appear in an empty space. You can walk around it and if I were on the street and I wanted to look at the building, what would I see? And previously you had to imagine that. And there are people in the world who can imagine 3 dimensions, and then there's 95% of the other people who cannot. And so suddenly this HoloLens provides you with a way of what would it look like if you were actually there all the way through. Well, I don't like where this pillar is in the construction, so can we move this left or right a little bit? So the level of interaction and collaboration, when you go look at many of those videos, which you can find on the HoloLens website, you'll actually see remote collaboration. So you and I today are actually doing this thing via video. But if we were looking at a shared space, you would see my avatar in the shared space, I'd see your avatar, and we would actually have a conversation about the thing we're collaborating on, whether it's a building or the Mars example that we've shown as well. Those avatars can start to collaborate in this virtual space as a different way of working with one another. So we've tended to think about working as about documents or phone calls or maybe video. But what happens if the two of us could insert ourselves into that three-dimensional space and have a conversation in 3D space? So it's not only necessarily about viewing things, it's actually about working differently. And I think that's going to be a new way of people experimenting and understanding how you can take people in disparate places and have them share. There's stuff you talked about, the Arthur C. Clarke stuff about, he actually projects people collaborating and sharing. He talks about remote medicine. And the remote medicine thing actually is manifested through HoloLens, through remote assistance. So you're starting to see a lot of the things he talked about. It's not just about text messaging or about Skype. You actually can do this remote assistance where you can be on an island somewhere and I can be over here, and it's as if we're right next to one another.
Yeah, very cool. The construction video that you talked about, I saw that. I actually went to the presentation that we had at Tech Ready, and not only can you walk around the outside of the building, but you could also walk into the building. Right, which was really cool. You could say, oh, I want this electrical outlet, over here instead of here.
So, I mean, what's great about that from a design perspective is that when you actually move the electrical outlet in 3D space, the construction drawings change. So there's actually change management against the construction drawings relative to that. That's a very cool thing.
Yeah, you don't have to tell anybody that you want it moved. You just move it, and it automatically updates the blueprints.
Yeah, the whole thing synchronizes, and again, because you've actually got the Windows 10 features, you've got document management, you've got document retention, you've got document versioning. All of that stuff happens because it really is a Windows 10 device.
So here's a question. Will I be able to get into a 1988 Chevrolet Chevette and have it turn into a Ferrari?
As long as you put the HoloLens on and imagine what it's like. I don't know if the driving experience is going to be quite the same. We can make the audio the same. We can actually make audio so you think it sounds like a Ferrari, but I don't know if it ever will drive like a Ferrari.
Yeah, and so I know I'll get a note on this, but yes, I am aware that Chevy didn't make a 1988 Chevy Chevette. What else do you have? That's a pretty cool technology, HoloLens, but we've got so much more that's happening and coming.
Well, so there's actually interesting derivatives that fall out of that, because in HoloLens, one of the things that's happening is a lot of video processing as well, because you're wearing a camera that's seeing things that the other people can see. And so we're starting to see very interesting things on video processing, and a lot of this is actually being driven by cars. If you actually think about industries that are transforming, we know that you've got the transportation industry with companies like Uber changing, but suddenly you've got Tesla in the marketplace that actually is a software company, and you've got the other car companies really being driven about how they can differentiate and what are the kinds of features that they've got. And so previously where a car with some rubber and steel and a motor driving around, now a car is actually a data center on wheels with networks and multiple CPUs and radar and cameras and lots of connectivity also driving around. And so the amount of processing that's going to go on in a car, we've seen this for a while. There's been parking assist for a while. You could drive your car up to next to a parking spot, take your hands off the wheel, and your car would magically parallel park. That's relatively easy from a video perspective. But most of the new cars have lots of video cameras around the side. And one of the places you've seen that is when you look in the mirror on the side of your car, and there's a blind spot alert. Suddenly you see a little indicator in your mirror that says, there's actually a car there. You can't see it, but I can see it. What kind of processing is going on when that happens? So if you ever try this, get on a bicycle and take a video camera with you and just, like a GoPro, and just, film what's going on in front of you. And then go back and look at the video, and you see it's all jumbly and it moves around and it's not very stable. So what is the kind of processing that it takes to take a badly shot video and produce something that I can now synthesize? In other words, can the video camera or the logic behind it detect something in the road? Can you detect a car that's stationary or a car that's moving? Can you detect a dog? Can you detect a pothole? And so that's seriously, compute-intensive stuff. And one of the things we're doing is some of it is algorithmic, and some of it is actually machine learning, because if the machine learning system can recognize a pattern of a dog, then you actually get more than just the algorithm can identify the shape of a dog. And so you're starting to see this merge of algorithmic processing and deep learning processing really helping you stabilize a video to actually be able to identify things. Because if I can identify that it's a pothole, I might take a different action than if it's a person in the street, or if it's a car, if it's a truck. There's another consequence of that, which is that if I've got the video that can see your car, how much do I want to know about your license plate on your car? Do I want to store that license plate, or do I actually want to provide some level of privacy that your license plate is yours and I don't want to see it? I want to know there's a license plate, but I don't want to actually process it. Because there's a lot of privacy attached to your license plate. Because if I can actually get that and process against it, I can find out who you are or who the owner is. It might not be you who's driving it. I can find out lots of things about the car. So there's lots of interesting questions about video processing as well as privacy that comes out of it. Even if you're just driving down the street, I want you to know that I was walking on the street. And so what I love about this is suddenly the car scenario is opening up massive things around compute, machine learning, privacy, storage, some store and forward stuff as well, because not every car is connected to the cloud all the time. They are partially connected, not even mostly connected. They're mainly partially connected. If you're driving in the country, you might have great connectivity. But if you're driving in New York City with all those buildings, you may or may not have connectivity. And so the compute thing that's going on in the car has to be capable of both compute, storage, store and forward, data analysis in real time, where you may or may not be connected. And so when you go back to a system design perspective, we've actually gone from non-connected devices to client-server, where we assumed always connected devices, then to mostly connected devices, which is I have a network most of the time, but some I might not, into system architectures that are rarely connected but capable. And how can I use cloud processing as a background to the thing that's going on in the car? So the system architectures as a consequence of video processing is actually getting super interesting, but it does mean that a car is going to have some pretty dense CPU capability to be able to process this stuff while it's moving.
Yeah. Things like storing data and then dumping it when connected.
Yep.
Yeah.
Well, one of the things we're discovering about the connected car scenario is for every byte that you send on the wire, there's a cost. It's a real cost. These things tend to not be like your phone. They tend to be more data billing-based things. And so when I send a byte, there better be business value attached to that byte that's going to justify the cost of the data going up and the data coming down. So now, for each one of these little applets that you build, on the car is one thing, but as you start to share, there has to be real value attached to moving those bytes back and forth. So some of the scenarios are kind of cute, which is, can I open my door remotely? Well, that has to have a value. But then it starts to get interesting on the video processing, which is, if I'm going to do crowdsourcing of maps from a car, so we know we've got some base level maps, but I want to actually get real-time maps to know there's a pothole. Now I'm crowdsourcing the maps from all the cars that are driving around. There's a lot of data to do that. Is the value of an up-to-date map worth the cost of the telemetry? Somebody needs to answer that question. And for some people, the answer is yes, and for some people, it's like, well, I don't care. So I love the case of superimposition of the business model on top of the technology, because it's fun to design the system, but does it really add value? That's sort of interesting.
Yeah, I can see it now. You drive by a pizza place and, all of a sudden you get a pizza place ad in the center of your dash.
Right. Actually, more interestingly, you're driving to the pizza place. The intelligent agent, Cortana, actually knows that that's the place that you go to, and therefore it phones ahead and orders your favorite pizza for you. So when you get close, you actually get a pop-up that says, by the way, your 12-inch with mushrooms and pepperoni is waiting for you. That's the place you really want to get to.
There you go. Yeah, that would be awesome.
So the intelligent agent is another one of these dimensions that we're going to see more and more, which is the more the agent understands about you and your habits, the more interesting it gets in terms of the advice that it can give you. And in some cases, the advice is advisory, like your pizza is available. But in some cases, the agent will do something on your behalf and then not even ask permission. It'll do it because you've given it previous permission to do something. The interesting question is, do you want to know when the agent's done that? Do you want the agent to come up and say, oh, by the way, this would do early in the morning. You're sitting and having breakfast, and it's cold outside, and the intelligent agent knows that you're going to be driving to work in about an hour, looks at the temperature, says, it's really cold. Maybe I should start your car and warm it up for you. Maybe I should reverse it out of the garage and put it at the front door for you. Do you want the agent to tell you that it's going to do that or ask you that it's going to do that? And the first couple of times it'll ask you, then you'll say, look, stop asking me, just do it. And so the cultural, personal interaction between you and the intelligent agent is going to get very interesting really, really quickly. We're seeing early things of that with Cortana popping up on your phone saying, hey, it's 5 o'clock. You normally go home at 5 o'clock. Here's the traffic. That's the start. It's going to get way more interesting than that the more the agent learns about you and your context. What will happen that starts to get sort of the next step is the combination of you at your home scenario, your personal scenario, and your work scenario, because if Cortana can look at your work schedule and your home schedule, it can maybe start to make some intelligent choices for you on the merge of those. There's an interesting compliance boundary because you're now crossing those two personas. You're blending that data, and some people may want that and some people may not. But the more the agent learns about your habits, the more the agent can help you get your job done.
Yeah, I think that's really interesting. And I think that there are some other scenarios that probably we haven't thought of, right? Like what happens if it's not your car? What happens if what if it's a company car?
Yep.
And your company, of course, would have the right to push policies to the car like, hey,
of course. Yeah.
You can't drive over 56 miles an hour, or hey, I don't want you ordering pizza from this car.
Or going outside a certain boundary.
Yeah, exactly correct. Or you can't go, yeah, that's right. GPS fencing.
Yeah, no. So all of those things are feasible, but what's interesting behaviorally, if you look at people's behavior, many people when they rent a car, recently, cars will have Bluetooth in them. And so the first thing you do when you rent the car is you get into the car and you hook up your Bluetooth on your phone because you want to actually do it.
Yeah.
But from that point onwards, all of your calls and many of your contacts are sitting in the car now. So the consequence is when you get out of a rental car, do you flush the onboard Bluetooth system? Maybe 1 in 1,000. So you're actually leaving a lot of privacy data back in the car. And the only reason I know this was I got into a rental car one time and I tried to hook my phone up and I couldn't because the Bluetooth number of connections was full. There were already 10 phones connected to the car.
Right.
So I went in and I deleted them. But the sense of information, dredges that you leave around, the footprints and breadcrumbs, I'm not sure that many people realize how many breadcrumbs they're actually leaving in different places today.
Right. Yeah. And I'm with you. I'm in a rental car almost every week, and yeah, I see the same thing. Normally, the computer in the car will come up and say, "Hey, do you want me to download contacts?" And if you're smart, of course, you say no.
Well, but a lot of people don't even do anything. They just, of course, yes, why not?
Yeah.
It's convenient. I love to do that. And then all of your contacts are now sitting in the car. And one of the interesting things with that is you don't log into the car. The car actually has an anonymous login for all users. But if you logged into the car with your persona, much as you'd log into a Windows 10 machine as a user, when you logged out, nobody else should be able to get to your context. But that's not the way it works. It actually works for convenience, which is there's anonymous login to the car.
Yeah, and what about driverless cars that have a specific path that they're following? Those cars could communicate with other cars, right? They could tell the car behind them, hey, in 200 feet, I'm going to stop and I'm going to turn left.
Yep. So we actually showed something at this past CES. We worked with a partner out of Germany called IV that was along that line. And the first thing you've got to do is have what they call the intelligent infrastructure. So it's the intelligent road, the road that can communicate, because the road becomes not only transport for devices, but transport for data. And so the scenario that we did was a pedestrian that had on a Microsoft band that was actually hooked up by Wi-Fi to the road infrastructure. And then a car coming along that was Wi-Fi connected. And what happens is the pedestrian was walking behind a van trying to cross the road. And the car that's coming along how does the car see the pedestrian behind the van? And you need the intelligent infrastructure. So the scenario was the pedestrian walks out from its behind the truck, the car's driving along, the car stops before the pedestrian enters because they can actually see that that's happening. That requires this very intelligent infrastructure. And so there'll be countries, places, cities, buildings maybe, where that intelligent infrastructure is built out, because you have to have very real-time response to do that. You have to know exactly where the pedestrian is in real time, and there are some communication mechanisms that may not be quick enough to do that. And so the ability of autonomous cars to get there and understand the data, understand the environment, and take action. So in my scenario where the autonomous car either slows down or stops, that's back to my example earlier, the intelligent agent doing something without asking permission, because the intelligent agent knows more than you do. The intelligent agent knows that there's a pedestrian behind the van, and therefore it knows it needs to stop, and there's not enough time to say, hey, Lex, can I stop the car? Because if we don't, we're going to hit somebody. It just does it. And then after the fact, you realize, oh, that was actually a good thing. Thanks for stopping. Otherwise, we would have been in trouble. One of the interesting constraints of autonomous cars is when there is a collision of some kind, which is going to happen in some way, who's accountable? If my car hits a lamppost, I'll forget people and dogs, my car hits a lamppost for some reason, am I accountable? Is the car accountable? Is the mapping vendor accountable?
Right.
So there are a bunch of policy questions that are going to have to be solved, I think, before we see this. In California, they recently introduced some legislation to kind of slow down the autonomous car work a little bit to start to get to some of these accountabilities.
Yeah. Do you even need to buy insurance for a car that you're not going to drive?
Actually, it's a different question. Who buys the insurance?
There you go.
Is it you, the driver, or you, the car company? You know, when you get into you buy a new car today, it's got this beautiful new touch screen, GPS, and all these other gadgets in it. And the first time you start up the car, your welcome experience, there's a whole bunch of stuff that scrolls by on those screens, and you say, yes, 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 of course, yes, 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 yes. And all you're doing there is relinquishing your data, you're selling them stuff, you're telling the car they can have access to stuff. But in the future, one of those disclaimers in the end user agreement that you're actually acknowledging in the car might be that we, the car company, are not responsible if you hit a lamppost, when you're driving autonomously. Even simple things today, like your car reversing out of the garage, which many autonomous things could do. Even I talked previously about assisted parking. So you're driving, you bought your brand new car, you actually can put some glassware on the roof to show how simple it is, and your autonomous car parks, misreads something, and whacks the car, one of those cars. Are you accountable? Who's accountable? So I think the policy questions are going to have to be solved. The technology is ahead of the policy, let me say that. And I think the policy questions are things that are going to have to get resolved, because otherwise we're going to have technology that we won't be able to use because of accountability.
I could see a whole hierarchy of policies, right? The car owner could set policies. The city that you're driving in could set policies. The state that the city resides in could set policies.
Yep. So actually, let's just go down that tangent a minute, because there's two things that come out of what you talked about. One is identity and establishing unique identity. And the second one is the ability to actually have authorizations against the identity, policies in this case. And policies might be generic to all cars of this type, all cars who travel on this road, all cars driven by guys with glasses. Or, there's some interesting policy that gets set up. And one of the things that we see happening is that your identity or identities, you might have multiple personas, your individual identities. How do those get attached to you? And do we know that you are who you are? And is this device, car, or person allowed to do the things that they're trying to do? Today, we think of policies from an IT perspective of, your device has to have this kind of software, or you're allowed to see these things and not those things, or you can use these features. But policy, as you describe right now, authorization, is going to get much broader than that in a very general way. So identity and how identity gets played out is very interesting. One of the big case studies we've been talking about for a while has been the work we did with Real Madrid, and Real Madrid, I should say the right way, the football team in Spain, and they've discovered that 400 million fans around the world. And so suddenly we had to find a directory system for 400 million people, getting that level of scale has been an interesting question of how you actually take directory systems up to that level of scale. But the real scale you want to get to is the IoT scale, where you have all these little devices and connections on everything that you touch around the world, and some of them will be secure, some of them will not be secure. The ones that are secure, you can have policy against. The ones that are not secure, what happens if they try to do something weird? How do you stop them? And so identity there is not 400 million, but it's probably 400 billion by the time we finished. And then against each one of those devices, I have to be able to have authorization. I have to have policy, because a simple IoT thing like you've got a wireless charger to your phone, and your phone can communicate to it and say when it needs to be done. Interesting. But when I've got everything that's instrumented, roads that are instrumented, we talked about intelligent road systems and intelligent devices, all of those things are instrumented. Now you've got an incredible number of devices. You've got privacy issues. You've got authorization issues. So that's probably going to be a place where we need to do a lot more work in the very near future. That can't lag, because this IoT thing is happening, or it's happened in some cases. The ability to identify the device, even something like firmware upgrade. So I'm sure that you update the firmware on your TV set at home just because you're a geek like me. And periodically you'll go see that your TV set has a new piece of firmware. But for many consumers, I don't think they think of their digital TV as a digital device. They think of it as a high-definition TV, and they can watch great football games on it. But I'm not sure they think of it as actually a pretty complicated computing device that has firmware, has software running on it. We're not sure whether it has antivirus software running on it. That's a different question. But in that sense, the ability to download new firmware to a little device. I've got a pen, and this pen is actually a communicating Bluetooth pen, so it probably has firmware. I have to register the device. I have to know whose the device is mine. I have to know what version of the software is. I have to know, is there a new version that's applicable to this version of the pen as opposed to another version of the pen? So everything we do with phones today, we've got firmware on the phone as well as software on the phones as a device. Now you're going to have billions of devices that need to be managed in the same way. Interesting, a lot of work that needs to be done there. But if you take that into your home, in your home, you're going to land up with some intelligent appliances. I just saw a coffee machine just launched that's a Wi-Fi communicating coffee machine. If you live in Seattle, that's a really important thing to know when you're running out of coffee and when you need to change the filter. But there are also going to be some unmanaged devices in your home. And so your home's probably going to have a security hub, which is going to be an endpoint that's a known point of secure connection. So from everything else, I'm coming into the device, it's a secure connection to the device, plus the things that device can do is secure. But on the other side of the device, I can have either secure devices or not secure devices. And what happens if one of those non-secure devices wants to do something? So let's say you got a lock on your door, your front door. I'm seeing some of these things right now. Either a front door that has a PIN number on it or a Bluetooth front door key. I'm walking up with my phone, and Bluetooth stuff is kind of easy to break sometimes. And so how do you treat non-secure devices with secure devices in the same blend? These are really hard technical problems. And I think that there are going to be some homeowners who jump in, who really understand it, and there's going to be a lot of homeowners who jump in who really don't understand the consequence of all of these nice widgets that they're putting in, whether it's in their home, their car, an airplane, their offices. I think that's going to change. One of the things that will change really quickly. If you just think back, when we were talking about IoT 2 or 3 years ago, the things we were talking about as being instrumented was really exceptional. Could you afford to do it? That's changed dramatically now. If you think about it, it's very hard to buy any piece of electronics today that's not connected in some way. I was in China recently, and one of the companies has an air cleaner. And it's a Wi-Fi connected air cleaner because the air cleaner can tell you when the filter is running out and send you an email that says, hey, I need a new filter. But what I like about that scenario is that's only the first step. I'd actually like the air cleaner to order a new filter. What value do I add buying a filter? The only value I add is my credit card. So if I have a subscription account set up, I can just have them send me a new air filter. I had no value by getting involved in that conversation. In fact, I'd really like to be able to open my front door one day, and there's going to be a box that's got an air filter in it. And then I say, oh my gosh, my air filter must be running out. I better go change it. And so the changing business models attached to all this IoT stuff, I think, is going to be the place where we're going to see some old companies changing, like my air filter company, and some new companies doing amazing things that are really going in and going to break open this business, and change what we do at home and at work in dramatic ways.
Yeah, absolutely. That's interesting. I don't know if you remember this. I'm sure you probably do. But remember the old House of Tomorrow or House of the Future that we used to have on campus?
Yep. Well, there was one at Epcot, if you remember. There was one that Disney had at Epcot for a while.
Yeah.
Which is kind of interesting when you go back and look at it. And then, at the old briefing center here, we used to have the House of the Future, which is actually now the House of the Past.
Right. Yeah. So in the old House of the Future, you would walk in, the scenario was, Dad comes home, he scans in, he gets in the front door somehow. In this case, I think it was a card key, if I remember correctly.
Yeah.
Right? Automatically sets the temperature that he likes, automatically sets the TV stations that he likes, automatically sets the lighting that he likes. Yeah. All of that stuff was really cool back then, but that's all child's play compared to, what we're about to see.
Well, not what we're seeing, and not the about part. We're actually seeing it. So there's this great project we've got with Deloitte, with a building that they have in Amsterdam called The Edge. And you can go onto YouTube, and there's actually some really good videos about it. But one thing, it's a LEED Platinum certified building. So it's green everything. It's fully instrumented. The lights, the luminaires are LED luminaires that are power over internet. It's all connected in the sense where you actually can measure and view things. But what's amazing about that building is it starts to get into this intersection between building and people. And the building actually has a persona, and the building has an intelligent agent that can help you do things. So the scenario you described at home is exactly the same in the building. So the way it's set up is like many of the Microsoft buildings today, but many of our customer buildings as well, which is there's no set offices. You walk in and there's some spaces. You go kind of grab a space where you want to work. And it's generally set up as a big collaborative area. You can sit on the side. You can sit in the middle. But the scenario in this case is I walk into the building in the morning, and I find a space that I like, and I touch it with my phone because there's an NFC tag in the table, and I register into that space. Then the building, much as you said about the home, recognizes me, so it changes the lighting, maybe the heat, plays my favorite music, does some things to create my environment in the office. But then, what happens if I'm in the building and then you arrive in the building half an hour later? Can the building do something and know something about us? Because today, if you and I were meeting a lot, when you come into the building, the first thing you would do is actually probably either text me or call me and say, hey, Norm, we're doing this video. Where are you sitting? Because I want to have a chat with you. And we'd sort of do this kind of voice texty thing. But wouldn't it be interesting if the building had access to my Delve? Because if it went over my office graph, it actually knows that you and I have been talking. We've been preparing for this. We've actually had a couple of Skype for Business conversations. We've traded some email. Therefore, there's an amplification of our collaboration, in which case it knows that when you enter the building, that you and I have a work affinity at that time, not necessarily last week, but this week. So when you walk in, you actually get a pop-up on your phone that says, hey, Lex, welcome to The Edge. We noticed that you've been working with Norm recently. He's sitting on the third floor in spot 17. Why don't you go join him there? You have an option. It's an advisory thing. You could say, not interested, I'm going to go get a cup of coffee. Or you can say, thanks for doing that because we have to do follow-up on some things. So now the building, that wasn't true in the house because the house stuff was all algorithmic. Now you've got the building synthesizing information between you and I and making some advisory decisions, which is, hey, you guys have been working a lot, so why don't you sit together? Maybe you'll be able to do some more work. So I think this stuff is actually getting very real to do that. Now, in the case of The Edge, it's a brand new building. All of these things could be built in. But some of that scenario could actually be done in a sort of a brownfield as opposed to a greenfield building, an older building that you have some instrumentation. The NFC registration has nothing to do with building infrastructure. If you've got Wi-Fi in the building, you can do the NFC registration in the building. So the stuff is very real today. That's not the future. That actually is what people are doing today. And it's interesting because it gets to the way people work. So at home, it was the way you collaborate and live your sort of personal life. But it's starting to change your work life. And we haven't seen this level of disruption since sort of Office. When people threw away their typewriters and started using Word, not even Office, but kind of Word and Excel and Multiplan, those kinds of tools. There hasn't been this level of change in the way this has happened. So you sort of had individual collaboration, You then had Office, where we tied some things together and said, these tools work better. Then we had team collaboration with SharePoint. Those were all sort of steps along the way. Now all of a sudden you've got this intelligent agent helping you be more productive. The same way as I can help you in the car by turning the heater on when it's cold, I can help you be more productive at work. And that's why when we started, I think what I was saying is that the future is now in many cases, is these things are very real and very doable today. And it's scaring some people a little bit because of the speed that it's moving at. And so I think that in some cases, the cultural behavior, not the technology. There was a while where it was the technology might have been slowing us down. Now it's the people. Now it's the ability of people to deal with this. The interesting question is it a generational thing? Is it just you and I with a little bit of gray hair who actually have less affinity to this? And, you know, the younger millennials coming into the workforce now, this is just the way they live. This is what you do. Why are you so worried about it?
It's just normal.
Yeah, it's life. This is what you do. You know, but I'll sit on Instagram. I'll send you a picture.
Yeah. Yeah, so here's the real question. If you and I are in the same office, you know, whose Delve settings take precedence?
No,
I imagine that there will be some sort of algorithm that looks through my music collection and your music collection and finds some common ground.
No, I actually think that that's what will happen. I mean, why not? In the sense of, if there's an overlap, then it actually say, hey, both you guys like Steely Dan or something else. You know, I could try that. Or not necessarily that you like Steely Dan, but you like something like Steely Dan, so I'm going to play some Brian Eno because it kind of fits in.
You can play Steely Dan if you want when I'm in the room. I love Steely Dan.
I'm not surprised with that at all. Me too. But that, so you can, because those are kind of machine learning algorithms, because the more the system learns about your context and your behavior, the more it understands about you, much like some of the music services do today. They listen to what you listen to and therefore say, you might like this. And as long as the things that are being advised to you are mostly things that you like, you're actually okay with that. But if it starts to go off track, which happens sometimes there's a jump on music affinity. We're like, where did that come from? I don't like this stuff. You have to go back and help the agent understand, which was good choice this time, not good choice next time. Let's move these a little bit more in that direction. But if you do that, you'll never spread. You'll never get the sort of random stuff that you really would like, but you just don't know about it. Or you've got a daughter who's 16 years old who's teaching you what it's like.
Yeah, and that's important, right? I've got friends that used to make fun of me because I'd go into Best Buy and buy, 5 or 6 CDs from people that I'd never heard of, just so that I could listen to them and figure out if that's something that I actually liked or not.
So the scenario now is an agent's going to make that suggestion to you, which says, I've looked at your listening patterns across all the music services, what you listen to in your car, and I think you might like this. Who's making the algorithmic decision behind that? Is it a music publisher who's actually biasing the music service by buying an ad to actually say, push me? Some of the underlying things are going to be very interesting that come out of that.
Yeah, well, hopefully there'll be some user input involved, like, hey, I made this recommendation. You listened to it. Did you like it or not like it? And then based on your response,
But actually what you'd like to get to is not to have to ask that question, but for the agent to understand it. What are the actions that you can do that are indicative to the agent that you liked it? Maybe you made it louder, or maybe you said, play me the next track, or maybe you stopped it in the middle and said, no, take me back to Steely Dan. The agent should be able to learn from your behavior. And so you've really got these two worlds. One is the declarative world, which is I like this, I do that. The other one is the observed world. And those two kind of intermesh. And the agent actually has to synthesize across declarative and synthesize to give you the best choice. The more you can make declarative, the better. But many people don't want to say, yes, I do, or yes, I don't. Do you like this or don't you like it?
Yeah. So, Norm, how do you see this affecting businesses?
So I think what's really important is actually taking all of this technology that we've talked about and how do businesses change, how do business models change, how do new businesses make money? And so we talked a little bit earlier about the air cleaner that'll send you an email saying, I've got a new filter, or just sends you a filter. Will you pay a subscription for that? In other words, do you feel comfortable going to the air cleaner company and saying, look, you've got my credit card, I trust your pricing, I'm locked in, just make sure that I've got a filter when I need it. You could say the same for ink cartridges. We've done some work with one of the elevator companies out of Germany, ThyssenKrupp, that has 1 million elevators running around the world, heavily instrumented, but their model is moving towards elevator floor as a service rather than selling you a piece of capital equipment. So they want to say, we'll make sure that in this building where there are 6 physical elevators, we'll make sure that you have enough capacity available at the time that you need it. Just trust us, you'll pay us for it, and we're going to charge you per elevator per month per floor, not necessarily $1 million to build that elevator. So I think one of the amazing consequences of this is there'll be new, very disruptive businesses, and you'll take someone like ThyssenKrupp that's been around for many, many years as an elevator company recreating itself, or somebody redefining air filters in a different way. So you have both entry points, older companies changing and new companies entering, and I think that provides a fantastic framework for us to take advantage of the technology and redefine how we live our lives.
Absolutely. I think it's going to be very interesting, and I think that it's coming faster than most people realize.
It is. Objects are definitely closer than you think.
Yeah, absolutely. That's awesome. That's a great analogy.
Yeah.
Well, guys, listen, we're about running out of time. Norm, I want to thank you so much for being our guest again. This is year number 3, and
Yep.
if you're willing, I'm more than happy to do it number 4.
Love to come back again, take a look back, but more interestingly, I'll take a look forward as well.
Absolutely. Well, guys, that's all we have for today. So that's your Taste of Premiere.